Assalamualaikum and salam sejahtera to Puan Dayana Sari. So this is our assignment presentations on advanced wafer cleaning techniques for tin gate oxide. Me, myself, Nurilam Sari, Mustafa Hazim and Suhinsan will present about this topic. In the outline, we have introduction, wafer cleaning technique, objective, flow of RCA cleaning and ozone cleaning, result analysis and conclusion. First, introduction. Cleaning is the most frequently repeated step in the IC production. The RCA clean, developed in 1965, still forms in the basic step for most front-end cleans. The objective of the wafer cleaning process is the removal of chemical and particle impurities without altering or damaging the wafer surface or substrate. The surface of the wafer must be maintained, not affected, so that roughness, corrosion, or pitting negates the result of the wafer cleaning process.
Okay, and now for the wafer cleaning technique, the chemistry used in standard wafer cleaning has remained largely unchanged during the last 30 years. It is used based on the RCA clean process that utilize acidic hydrogen peroxide and ammonium hydroxide solution. While this is the primary method still used by industry, what has changed recently is implementation along with new optimized cleaning technology that include ozone cleaning and megasonic cleaning system. Manufacturing integrated circuit require hundreds of precise processing steps depending on the specific device type. Most of the steps are completed as single processes on the complete wafer before they are diced into individual chips. About 20% of the steps are wafer cleaning process, which highlight the importance of wafer cleaning and substrate surface conditioning. So moving on with Sunil for the objective. Thank you.
Okay, hi. So next I gotta present about the objectives for this paper or this assignment. So in this assignment, we are trying to make a comparison between RCA and ozone cleaning process to determine the advanced wafer cleaning technique for tin gate oxide. Let's see more detail. Okay, first is RCA clean. RCA clean is contain 4 major chemical steps performed in following sequence. First step is SPM. SPM is used to remove organic contamination originating from transportation in wafer carriers, residual photoresist, or organic absorption from the atmosphere. And the material used in this step is sulfuric acid and hydrogen peroxide mix. Next, the second step is APM. APM is used to oxidize light organic, remove particles, and grow a thin layer of clean oxide to protect the contamination-prone bare silicon. And the material used in this step is ammonium hydroxide, hydrogen peroxide mix. And the third step is DHF. It is used to remove the thin layer of contaminated native oxide. And the material used in this step is diluted hydrofluoric acid. And the last step is HPM. HPM is used to first oxidize, then compress metallic on wafer surface. And the material used in this step is hydrochloric acid and hydrogen peroxide mix. Okay, next is about the ozone clean. The ozone clean contains 3 major chemical steps and performed in following sequence. First is SOM. SOM is used to remove organic contamination, more or less the same function as the SPM step in the modified RCA clean. And the material used in this step is sulfuric acid and ozonated water mix. And the second step is DHF. So DHF is used to remove the thin layer of contaminated oxide, and the material is diluted hydrofluoric acid. And the last step is ozonated water, and is used at last step to oxidize and rise away light organics, metallics, and 19 particles, and at the same time grow a thin layer of clean oxide to protect the bare silicon. Okay, that's all from me.
Okay, for result analytic, two research was done by us using the modified RCA cleaning and ozone clean. For the chemical use expert over time, for RCA clean was SPM, which is 60 seconds, DHF 0.5%, 90 seconds, APM 90 seconds, and HPM 90 seconds. For the ozone clean, SOM is around 60 seconds, DHF of 0.5%, 90 seconds, and 0O3H2O about around 210 seconds. And after the comparison were done, we can see the residual transition method label of ozone clean and over modified RCA clean. There are the result, and the result shows that the ozone clean is far more superior because of hydrophobic wafer surface has a contact angle of 55 degree or higher, and ozone came closer than modified RCA. Also, the residual particle level are slightly higher than the modified RCA clean. Lastly, for ozone clean and chemical use is only H2O SO4 and HF rather than modified RCA which use additional of NH4OH, H2O2 and HCl. This shows that ozone clean is far more cost efficient rather than modified RCA. Thank you.
So, in conclusions, the ozone clean is the advanced wafer cleaning techniques compared with the RCA clean. OSHA requirement in this process is Part 2 identifications of chemicals hazardous to health. Employer have to identify and record in a register all chemicals hazardous to health used in the place of work, and the register shall be accessible to all employees at the place of work who may be exposed to the chemical hazardous to health. Second one is part 11, which is warning sign. Where a chemical hazardous to health is used in any area that is hazardous to health of any persons who may be in that area or who may be being at risk of being affected by the chemicals hazardous to health. The employer have to ensure that warning signs are posted at a conspicuous place at every entrance of the area to warn persons from entering the area of the hazard, and other relevant informations are given to persons who may be at risk of being affected by the chemicals hazardous to health. For the purpose of sub-regulations, the warning shall give warning of the hazard, be written in the national language or and English language, and be printed in dark red against white background. So that's all. Thank you.